Assalamualaikum. We are from class F4AS 120217R, and today our group will present techniques in differentiation. These are my group members. Differentiation is one of the fundamental tools in calculus that allow us to understand how quantities change in relation to each other. It is widely applied in physics, engineering, economics, biology, and many other fields. In mathematics, differentiation helps us to determine the slope of a curve, rates of change, and identify maximum or minimum points in functions. Question number 1. Explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is the process of finding the derivative of a function. The derivative measures the rate of change of a dependent variable with respect to an independent variable. For example, if y equal to function of x, the derivative dy over dx tells us how y changes as x changes. Graphically, the derivative at a certain point represents the slope of the tangent line to the function at that point. In real-world application, derivative can represent velocity, rate of change of position, acceleration, rate of change of velocity, and many more. Here are some of the techniques of differentiation in calculus. Number 1, we have power rule, which is the derivative of x to the power of n is n times x to the power of n minus 1. Number 2, we have constant rule. The derivative of any constant is 0. dy over dx of a constant equals to 0. Number 3, we have product rule. When multiplying two functions, the derivative is the first time the derivative of the second, plus the second times the derivative of the first. Next is quotient rule. When dividing two functions, the derivative is the bottom times the derivative of the top, minus the top times the derivative of the bottom divided by the bottom square. And not to mention chain rule, used for composite functions. Take the derivative of the outside function, then multiply by the derivative of the inside function. And lastly, we have implicit differentiation. It is used when y cannot be isolated. Differentiate both sides of the equation with respect to x and apply chain rule when differentiating terms involving y. Differentiate both sides with respect to x, treating y as a function of x, and apply the chain rule when needed.
Next, we move to question 2. In this question, we are asked to find the derivative dy over dx for two given functions using appropriate differentiation rules. For part A, the function is 3x squared sec x plus 2. This expression is a product of two functions of x. So we apply the product rule, which states that the derivative of uv is equal to uv prime plus vu prime. First, we let u is equal to 3x squared, and u prime is 6x, which is the power that we bring to the front, and we multiply the x with 2 and we will get the 6x. For v prime, when we differentiate sec, we will get sec x and 10x, and then sec x plus 2, 10x plus 2 multiplied by dy over dx, x plus 2, and we will get sec x plus 2, 10x plus 2. For next question, we move to question B. The function given is y is equal to 4x plus 2 over cos x. When we get the rational function like this, we know that we need to use quotient rule to solve this question. For u, for first step, we let u is equal to 4x plus 2. U prime is equal to 4. For v, we let v is equal to cos x, and we differentiate cos, we will get v prime is equal to negative sin x. And we substitute the value to the quotient rule, which is vu prime minus uv prime over v squared. We must remember this formula because some students always mistakenly use the formula and mess up the formula. And then we substitute the value to the formula. We will get cos x multiply 4 minus 4x plus 2 multiply x sin x multiply negative sin x over cos x squared. And then we simplify the equation, and the equation will be 4 cos x plus 4x plus 2 multiplied by sin x over cos squared x. And that's the final answer for this question.
So we move to the question 3, which is giving y ln 3x minus exponent of power of 2x plus 1 minus tan for y equal to 0. Find dy dx using implicit differentiation. For this case, we must differentiate one by one. So for the step one, y ln 3x, we use this equation, uh, use the product rule, which is uv prime minus vu prime. So we get a u is y, v is ln 3x. For u prime will be equal to dy ds. V prime 1 equal to 1 over 3s, but we need to substitute the 3, which is we multiply by 3, and we got 1 over s. So dy ds equal to u v prime minus vu prime equal to y 1 over s minus ln 3 dy ds. So for the step 2, we differentiate the power of exponent power of 2x plus 1. After we differentiate it, sorry, in this case, differentiate the power. So differentiate the power, we will get 2. So 2, so the actual answer is 2 exponent power of 2x plus 1. So we move to the step 3. We differentiate tan for y. D over dx tan for y after we differentiate equal to 4 secant square for y dy dx. After we all differentiate all the equation, we move to the step 4. We write again the differentiation. So y over x plus ln 3 x dy dx minus 2 exponent 2x plus 1 minus 4 secant square for y dy dx equal to 0. So we different dy dx. So dy dx will be over to the left, will be at the left. So the answer will be ln 3x dy dx minus 4 secant square for y dy dx equal to 2 exponent 2x plus 1 2x plus 1 minus y over x. After that, we merge together in one bracket for dy dx. So dy dx ln in the bracket dy dx in the bracket ln 3x minus 4 secant square 4y equal to 2 exponent 2x plus 1 minus y over x. So the final answer, you need to find dy dx. So the final answer for dy dx equal to 2 exponent 2x plus 1 minus 5 over x over ln 3x minus 4 secant square for y.
Question 4, which is the question instruction, is use linear approximation to estimate the value of square root for 80.99 minus with 2 over square root 80.99. Correct to 3 decimal places. Formula for linear approximation is f in the bracket x naught plus delta x equal to f in the bracket x naught plus with f prime x naught multiple with delta x, where delta x is equal to x minus with x naught. X is the given value, x naught is estimated value. Go to the equation, square root for 18.99 minus with 2 over 8 square root 18.99. Step 1, we will let fx square root 4x minus with 2 over square root x. We replace 80.99, which is given value. It will be x power 1 over 4 minus with 2 over x 1 over 2. It will be x1 power 1 over 4 minus with 2x power negative 1 over 2. Step 2, which is we will differentiate the function. So f prime x equal to 1 over 4x
negative 3 over 4 minus with x negative 3 over 2. The answer will be 1 over 4x power 3 over 4 minus with 1 over x 3 power 2. 3 over 2. X equal to the given value, which is the given value is 18.99. X naught is the estimated value, which is the x naught is 81. So the delta x is equal to x minus with x naught. So we will get negative 0.01. Step 3 is we need to substitute in the number into the formula. Square root 4 18.99 minus with 2 over 18 square root 18.99 equal to f in the bracket 81 plus f prime x in the bracket 81 multiple with delta x, which is delta x is negative 0.01. Square root 4 81 minus with 2 over square root 81 plus with 1 over 4 in the bracket 81 power of 3 over 4 minus with 1 over 2 in the bracket 81 power 3 over 2. So multiple with 0.01. How can we replace from the x given, we replace by the estimated value? After we substitute, we will get the answer is 3 and minus with 2 over 81 plus with 9 over 4 in the bracket 27 minus with 1 over 2 in the bracket 729 and then multiple with negative 0.01, then 241 over 81 plus with 1 over 108 minus with 1 over 1458. I will multiply it with negative 0.01. Then the last and final answer, it will get 2.778, which is correct to 3 decimal places. So, for conclusion and recommendation, in summary, we have explored several essential techniques in differentiations, including the basic rules, the application of derivatives to composite and trigonometric functions, implicit differentiation, and linear approximations. Each method plays a crucial role in helping us understand how functions behave and change, which is fundamental in both pure applied mathematics. Throughout this video, we aim to not only solve the equations, but to also demonstrate how each technique is connected and applied in different scenarios. This structured approach helps build a deeper understanding of calculus, especially for students encountering complex problems. We recommend regular practice, visualization tools, and group discussion to deepen understanding and improve accuracy. That's all from me.